Hello everyone, welcome back to the video series of signals and systems. So in this video we are going to learn about two different types of exponential signals. One is real exponential signal and second is complex exponential signal. So if you are first time to my channel, please consider subscribing. So real exponential signal. Okay, so real exponential signal. So real exponential signal, its general representation is x of t is equal to a into a power at. Okay, so a is amplitude here and small a is a real number. Okay, so depending on the value of this small a, we have three different types of signals in this real exponential signal. So x of t is equal to a into e power at. So first case we'll take it as a is equal to 0, and second case we'll take for a greater than 0, and the third case we'll take a is less than 0. So when a is equal to 0, when you substitute small a is equal to 0 here, so what we are left over here is x of t is equal to a, because e power 0 is equal to 1. So x of t is equal to a. That means if you draw this signal, so this will be x of t and its amplitude is a. That means it is a DC signal. Okay, so it is a DC signal. So real exponential signal will become a DC signal if the value of this small a is equal to 0. Okay, so if a is greater than 0, what will happen? So at when a is equal to 0, x of t is equal to a. So now a is greater than 0, so what will happen here is this is your x of t and t here. So if you draw this, what will happen? So it increases linearly. So it increases linearly. So value here is a. For positive time it increases with increase in time, and for negative values it decreases with increase in time. Okay, so it decreases here with increase in negative values, and for increase in positive values it increases exponentially. Similarly for a less than 0, so for a less than 0 the case is opposite. For negative values it increases and for positive values it decreases, because when a is less than 0, so it becomes now a into e power minus 80, because it is a value is negative, so it becomes a into e power minus 80. For positive values, that is t greater than 0, it decreases exponentially. Okay, so it decreases exponentially, and for t less than 0 it increases exponentially. Okay, so at 0 its value is equal to a. So this is your x of t for a is less than 0. So the opposite case of a greater than 0. So here in this case t, when t greater than 0 it increases exponentially, and for t less than 0 it decreases exponentially, and here it is a constant which is a DC signal. Okay, so this is about real exponential signal. Okay, so next we'll discuss about complex exponential signal. So complex exponential signal. So complex exponential signal is generally represented as x of t is equal to a into e power st, where s is sigma plus j omega, is a complex variable because it contains both real part and imaginary part, so it is a complex variable. So s is complex variable, and since it is written as exponential of the complex variable, so it is called as complex exponential signal. Okay, so based on different values of the sigma, omega and s, that is combined value of sigma plus j omega, we have different types of complex exponential signal. So we'll write it as cases and then we'll analyze each and every case. Okay, so in the first case, case 1, so we'll take s is equal to 0. When s is equal to 0, then what will be x of t? So x of t is equal to a. That means it will be a DC signal. So if this is your x of t versus t, so it will be a DC signal for all time. So its amplitude is equal to a. So for case 1, that is for s is equal to 0, so this will be a DC signal. Okay, so now consider case 2. So considering case 2, now when sigma is equal to 0, when sigma is equal to 0, then what will happen? S becomes now j omega. When s is equal to j omega, what is x of t? X of t is equal to a into e power j omega t. So j omega t can be written as cos omega t plus sin omega t. That means it will be a condition for sustained oscillations. Condition for sustained oscillations. Okay, so this will be the x of t in this case. So when sigma is equal to 0, s is equal to j omega, so x of t is equal to this. So it will have a constant frequency, that is omega, constant frequency. So output is constant amplitude and frequency of oscillations. Constant amplitude and frequency of oscillations, or it is called as sustained oscillations. Sustained oscillations. So we'll call it as sustained oscillation. So this is case 2. In case 3, we'll take in case 3, let us take omega is equal to 0. So when omega is equal to 0, then s becomes sigma. So x of t now becomes a into e power sigma t. So this is same as the previous case, that is real exponential signal, where now a is replaced by sigma. So now we have two cases again. When sigma greater than 0, sigma is less than 0. When sigma is greater than 0, exponentially increasing function, we'll call it as exponentially increasing function. And the graph for this I have drawn in the previous case also. So it will be like this, exponentially increasing function. This is x of t versus t. And this is for sigma less than 0, it will be exponentially decreasing function. Exponentially decreasing function. So the graph will be like this. Okay, so this is x of t versus t. Okay, so this is the case 3 where omega is equal to 0. Now s becomes sigma and it will become the complex exponential signal will be converted into real exponential signal. In this case, complex exponential signal is converted into real exponential signal. Okay, so next is case 4. Case 4, we'll consider s is equal to sigma plus j omega and also sigma greater than 0. So when both sigma and j omega are present and sigma is greater than 0, so how will be the output waveform is, since sigma is greater than 0, we'll have exponentially increasing signal. Exponentially increasing signal. So just as this case. So this diagram is repeated here. So this is also the replica of this. So this is exponentially increasing signal. So this is exponentially increasing. Since only sigma, if only sigma is present, this is okay. But we have now sigma plus j omega. So what is x of t then? A into e power sigma t e power j omega t. Since sigma is greater than 0, so we have the output like this. Okay, so such type of output is called as exponentially increasing sinusoidal signal, because the output is both combination of exponential and also sine. So since it is increasing exponentially, so it is the combination of increasing exponential sinusoidal signal. So these two, that means case 3 sigma greater than 0 case and case 2 are going to be multiplied with each other. Okay, so the first case of case 3, that is A, if you consider it as A, 3A and 3B, so it is the combination of 3A and 2. So second case and 3A case, it is the combination of both second case and 3A case. Okay, in the case 5, we'll consider S is equal to sigma plus j omega and sigma is less than omega. So that means this is the combination of the cases 3A and 2. So then in this case also, so what we'll get? So first of all, we have to draw this signal, exponentially decreasing signal, and replica of that. Okay, so if you draw this signal, it will be like this. So this type of output or this type of signal is called as exponentially decreasing sinusoidal signal. Okay, so this is the cases, this is the combination of 3B and 2. Okay, so this is the 5 cases of complex exponential signal. Okay, so hope you like this video. So if you like this video, please share with your friends and please subscribe to my channel. Thank you.